Idziesz na backstage, Ola?
Pójdę.
Okay. There is no one yet. Okay, we have 22 people. Okay, so I think we can slowly start. Hi, hello everyone. I'm really glad that we could meet all together today online, but also on-site in our office in Gdańsk. I hope you will enjoy our today's meeting. The first speaker will be Akif. He will tell us about functional effects system and his experiences regarding that. After the Akif's presentation, there will be about 20 minutes break. So those who are with us in the office, of course, will have an opportunity to, we'll have an opportunity to networking, but also grab some pizza or something to drink. And after the break, we will have the next presentation. The presentation belongs to Wojciech, who is with us today in the office. This is Wojciech. He will tell us about love, hate, and workflows. And please stay with us until the end, because we have also a short quiz on Kahoot for you. Of course, it will be based on the presentations. And of course, we have small prizes for you. So those who are attending us online, and if you win the prize, you can write to me on email. It's in the stream's description, but also it will be provided on the YouTube chat. And yeah, if you have any questions, you can ask on the chat on YouTube, but also here in the office, of course, after the Akif's presentation. And well, I think we can start. Akif, let us know if you are ready.
I am. Can you guys hear me well?
Yeah, we can see you.
Okay.
And hear you. So,
okay. So
your presentation.
You can see my screen too, right?
Let us know on the chat if you can see everything. Yeah, but I think it works, so no worries. You can start, Akif.
Okay. So, hello everybody. My name is Akif. I'm a software engineer at Scalac, and today I'm going to talk to you about the things I learned building a functional effect system and functional effects in general. So, let's start. First of all, if you have some experience with functional effects and Scala, and if you are in the community, you might wonder another effect system, why? And I'd like to start with answering that. Well, why not? That's my short answer. But in all seriousness, I got this idea of trying to build my own functional effect system after watching the presentations of Kit Langton and Adam Fraser. They do this video series called Symposium, and it's really great. If you haven't seen the episodes, you should definitely go check it out. And my goal was to try and understand these complex structures better. Different techniques that are involved in building such functional effect libraries, and also I wanted to have my own library. I wanted to be a library author, not just a library user. So I started working on this library, and I called it Effect because naming is something that's really hard, and I like simple names. Effect is a very simple name that explains what this thing does. So let's begin. I'm going to talk about functional effects and functional programming in general, and in fact, I'm not going to talk about it too much in detail myself, but I added this piece of code from read it, and it's written by John DeGoes. I think this paragraph, this couple of sentences explain what functional programming is and what functional effects are. So it essentially says that functional XYZ is some immutable way of modeling that XYZ. So in the sense of effects, this is covering mainly the side effects, but it is a way to represent them as immutable values. And the key points here for functional effects and functional programming in general are these three things: immutability, referential transparency, and the separation between description and execution of things. So this is what my work is based on. Let's continue. So what is effect? The effect type that my library brings. It is a functional effect system type, but it has some special features, at least special to me, that are related to error handling, and that's something that I'm going to be talking about as well in this presentation. Effect type has one type parameter. It's a generic type, much like other effect types that we know of in Scala. But this type only has one type parameter. I called it A, and it is the type of this value that this effect can compute. So essentially, effect is a description of a computation that can successfully produce a value of type A. This can be integers, strings, your custom types, etc. Or it can fail with an error type while doing this computation. This error type is special, and I'm going to talk about that later. It can fail unexpectedly due to some exceptions, and this is represented as throwables, or this computation can be interrupted. So effect type gives you these abilities, and if you are familiar with Scala functional effects or Zio library, you can think of this effect of A as mentally equivalent to this Zio of any E A, where this E type, error type, is fixed to my own error model. I'm going to show you that soon. And there is no dependency, and the R type parameter is set to any. So effect A is roughly equivalent to Zio any EA. And effect is just providing you with a functional effect type. It's not a complete solution to everything. It's not a silver bullet that's going to make your app perfect. It is going to give you a functional effect that has certain features. So let's continue. Here is just a quick look at what effect looks like. Since functional effects are descriptions of computations, there are different ways to construct them. And this first line is, let me see if I can enable my laser pointer here. Yes, perfect. So this effect here is building a description of computing this pure value. It is an effect that when executed, it's going to successfully produce this value 42, meaning of life. Another version here is similar, but it is actually wrapping a side effect. And what we'll see in a moment that this isn't actually running this println side effect and printing something to the screen, to the console, but it is a way to describe printing hello world to the screen. So this is in fact a functional effect. It is describing the side effect of printing something. So this is very simple construction. These are very simple construction examples using the apply method here. You can also construct functional effects that are meant to fail or be interrupted, etc. And this is an example of how you can build an effect that is going to fail. And here's an example of what my E error type looks like as a dummy example here. I'm creating an error with some numerical code, with timestamp information, with some additional metadata, etc. So let's continue. And what can you do with this functional effect? Well, in order to build programs, what we usually have is we have a main method, and our application starts from that point, and the instructions are run one by one to run our application logic. With the functional programming world, this can be a bit different, and it is different in the sense that we try to write everything in pure functions or functional effects when things are not pure, and this has the tendency to just spread around your application code. Everything becomes an effect at some point, and you will eventually need a way to run this application. The key thing I keep mentioning, that effect is a description, also plays a role here, because we keep describing things. We never run it until this main point. So this is what a main method can look like in a functional application. My library provides this effect app, similar to like Zio app, IO app, etc. in other libraries. And what it essentially requires you to do is to give it one root effect. And this effect is going to be the description of your entire program tree. And here's just a small example of a greeting application. It is going to print this information on the screen. It's going to wait for you to type something, and then it's going to greet you with that input, and it's going to terminate. This entire for comprehension here is actually a series of functional effects combined in a sequential way using flat maps. I'm going to talk about that later, but this is essentially how you would write a functional version of this greet app using effect, my functional effect type. So I promised I was going to talk about errors and handling, so I'm going to do that now. Before I explain my approach, I'd like to mention a couple of things, especially about the types of errors. Usually in our programming, there are these three types of errors, and it is important to have this distinction, because it's going to affect how we write our programs, how we treat our values and errors, etc. So what are these three types of errors? First one is just simply an error. It is something that is part of our application domain. It is the type of error that we expect to happen. So for example, if we are building an application form that asks user for some input, and we want to validate that input, there are these validation errors that we expect to happen. We ask someone for their age, and they input something that is other than a valid age. we expect that kind of error to happen. It's part of our application logic, application domain. So these types of errors should exist. They already do exist in our applications, and I simply want to call them errors. There is another type of error which I call unexpected error, and this is usually occurring because of some exceptional, unexpected situation, and there is usually not much to do about this kind of errors. Example of this could be I don't know, SQL exception, IO exception, timeout exception, etc. I keep saying exception because this is aligned with what unexpected errors are, what I call unexpected errors are. And that's why this exception name is also used in JVM, because such errors are modeled like that. And as I said, there is usually not much to do about these. Perhaps you can retry in certain cases, like you're calling an external server with an HTTP request and it returned it through a timeout exception, which could mean it's a temporary issue. And if we were to wait a bit and retry, we may succeed. So there are certain cases that we can do things about unexpected errors, but that's mainly it. It isn't really part of our application logic or domain. So there's that. And the third type I want to talk about is fatal errors, and it's just beyond the scope of my presentation here. It is an error that kills your program, and you don't really have too much to do about it. So one example is out of memory error. Your physical resources are not enough. You received an out of memory error. There isn't much to do about that, so your app dies. What I am focusing on in this errors library are the first two types, error and unexpected error, and let's talk more about that. So as a rule of thumb, I don't like calling these best practices, because there may be better practices than my best practice. So I like to call them rule of thumb, because this is what I do. So first thing is treating errors as regular values, pure values. And when I say error, I almost always mean the domain error, the first type of error here. So I am treating them as just regular values, just like how a user object is a value in my domain. User not found error is also something that I expect in my domain, so that's also a value. And the second thing is, don't depend on unexpected errors for program control. What this means is that if I am building a program about loading users from a database, I may expect that user is not there for a given ID, for example, and that user is not there, user not found case is a domain error for me. But SQL exception, like timeout exception, connection exception, etc., to the database is an unexpected error for me. So for my program flow, I should not depend on such unexpected errors. I should be aware that they may occur, but I should prepare a plan for that scenario. But I should not treat a timeout exception, for example, as a regular error and treat that error in my program like the user is not found. We don't know that, because that's not the result that we got. We got something else. It's an unexpected situation. So these two rules will help you write better programs, better functional programs, let's say. because they help me. And before I move on, I also want to explain this E here. I called my error type E because I had this idea before and already worked on another library called E. Why this exists is because based on all the things I explained, I saw that errors are not similar. Not all errors are similar, but most of them actually are, especially the domain errors. So what I mean by similar is that they contain similar information. They contain a message that is describing what is wrong. That's for sure. When I have an error, they convey me this information that something is wrong, and I understand what is wrong from that error. And optionally, they have some additional separate groups of data. So based on all these, I came up with this class. I called it E because it's short for error. It is meant to be used in many places, and I wanted to have a single structure for all my errors. That's why I came up with this. That's what this E library is about. You can check it out if you are curious. But that library was meant for solving something else. It was solving how to model an error. But this effect is for functional effects. And since I had this idea and I already had something to work with, I wanted to incorporate this error into my functional effect. And I basically have this error model here, which contains a message that is not optional. There's always going to be a message, but it also contains some numerical code, some kind for the error. It's like type of the error, some additional way to describe it. It may have a timestamp to know exactly when this error occurred. It may be caused by other errors, so it has a list of, it can have a list of causes, and it can have some arbitrary key to value related data. So, are we good so far? Is there any questions? Okay, moving on. So now we have some idea about what functional programming and functional programming with effects are. I talked about my approach to error handling, and now I want to talk about the techniques that I followed in building this library. So the very first thing I did was starting with very little code when I started writing this. These lines of codes are actually the very first few lines of effect library. If we think back and think about what a functional effect is, it is a description of a computation. I want to describe how to compute a value of type A, and I want a way to run this so that I get that A. So if we put these words into Scala code, this is what you come up with. So you want something that you want to call an effect, and you want it to be generic so that you can have an effect that is going to produce an A. And you want to have a way to run that, so you have a run method that returns A. And now how you can create this effect instances can depend on your implementation. But one technique that I followed is this declarative encoding thing. What that fancy looking name means is that I'm encoding my implementation in a couple of different subtypes. And what this what this eventually means that I have to think about what possible types that this effect can have, and the most simple case that you can think of for a functional effect is that it is successful. It is trying to it is giving you, it can give you the value A that you are trying to compute when you run this. So again, when you put this into put these words into Scala code, this is what you come up with. And this is sort of the base case for an effect. An effect can be a value. And when you encode it like this, what you end up with in the implementation of your run method is this this value apply thing. And I'm going to focus on these parts. So from the beginning, I followed this technique of being lazy. What this means is that when you are trying to build an effect, and you want this effect to describe what you want to compute, not actually compute it when you build it, you need to work with lazy values. And how can you write lazy values? Like this in Scala. I am using a lazy parameter here, also known as by name parameter. This apply method is taking a value from you, but it is a lazy value so that until you actually mention this value parameter here, it is not going to be evaluated. And this is basically it, how to make it lazy. You make it a lazy parameter. And since I want to build a successful effect here, I want to wrap it in value class. And case classes cannot have lazy parameters, so it is actually a lambda that doesn't take a parameter. So that's just some minor implementation detail, but the key thing is that this thing is lazy by default. This leads to separation of what the program is and how this program runs. It was, if you remember, one of the fundamental things I talked about at the beginning, that functional programs need to be mutable, they need to be referentially transparent, and you need to have clear separation between what a definition is and what a description is and what running things is. So that allows me to do this. Moving on, I started like this to build an effect, but I only have a way to build successful effects. I only have a way to construct effects that are going to give me some value, and I cannot program with just that. So I want one more feature. I want to be able to combine my effects, because that's what we do in functional programming. We write small pieces of functions, small pieces of core logic, and we have some ways to combine these. It's much like building Legos. It's much like playing with Legos. So we build pieces, and then we have ways to put them together to build some bigger thing. So the most intuitive thing to combine two effects is to sequence them. We run one and we run another one after that. So in Scala, in functional programming, this is done with flat map. What this essentially means is that you run one effect, and when you have a successful value from that, you run the other effect, and it is going to access the success value of the first one. And how I can do this is that I update my effect trait and I add this method. I have a flat map which expects me to give it a function from A, the success value of this particular effect, to another effect of type B, which means that I run this, I get an A, and I know how to get an effect of B because that's what you provide me. And moving on with the declarative encoding I mentioned, I create another piece of this effect. Effect now can be two things. It can be a value, it can be a flat map. What this flat map case class is that it is the description of flat map operation. It is having an effect of A, having the next step as a lambda function from A to effect B, and when you have this, the description of how to do this becomes this part here. I have this F and I'm going to provide it an A, and how I can get that A is if I run effect thing first. I am running effect first to get an A, and then I am running F, which means that I'm running effect B. You can already see that I was able to sequence the effects. I run one and I run the other one. So moving on, I want to keep building on this. I want to have a way to convert the success value, because I am building such a thing that I want to use in my programs, in my functional programs. I want it to have a good API for the user. Remember, I am trying to write a library, so it is important that your library has enough features and an easy to use interface for your users, so that they can easily use your library to build their own programs. So one common thing that we do in Scala and in functional programming is that we want to convert the successful values, and that's where the map method comes in. But if you are careful, I am not defining map as another case for this effect, because I noticed that I am actually able to implement this map in terms of the functionality I already have. And that's the technique I want to highlight here, is that you need to decide what is the core part of your domain, and what you can already implement in terms of other things that you have. And here what I do is I am implementing this map, which has this signature. It's just converting A to B, not A to another effect of B. So I am actually reusing flat map here, and the lambda function I give it is this. It is from A, and I am using given F here to get a B, and I am building another successful effect from that, because that's what flat map expects me to do. So that's one more technique. Another step forward is I want this thing to be able to fail. I want my functional effect to be able to fail, and I want it to be able to fail in a certain way. Because of the things I explained, I wanted to use my E type as the error type. So what it means to be able to fail in Scala is that we can return an either. I am choosing to do this because I want my domain errors, my E, to be a regular value, just like the value that this thing can produce A. So how I can model this, Scala already has the answer, either. If I update my run method to return an either A as either E as the error or A as the success value, even just by the function signature, we know that this thing may fail now, because the returning value may not be A, it may be an E. So what this means that I, of course, update my other implementations like flat map and map here to also reflect this change. But what this means is that if things can fail, how I can produce an effect of a given type. That's where this fold case comes in. It is also aligned with this technique of what's core and what can be implemented in terms of others, because I want my effect type to have certain capabilities to deal with these errors. I want to be able to build an effect that can fail. I want to be able to handle an error and convert that to a value. I want to be able to do other things with the error. So when I thought about all these cases, the most core case that can handle every possible type was apparent, and it was what is called fold, because it's going to fold over all the possible cases of this effect, and it has this sort of a signature. I know the code is getting more complicated, so I'm going to speed up here, but I am trying to walk you through my thought process in building this. So I need to handle all the cases. So I need to have one case for if this thing was an error, and I provide this lambda. It is taking the E, that is the error, and it is giving me another effect. It is taking the A in the if value case, that is the success value, and giving me another lambda. So when you model fold in your declarative encoding style, this is what you come up with. You have an effect of A, and you have a way to deal with its error to get an effect B, and you have a way to deal with the success case to get an effect of B. And how you run this now becomes this part. I don't know if it is readable to you, but what I do is I run the effect to get the either, and I actually use the fold method this either already has, because it also needs to solve this problem that the value can be both one of two cases. So I am just reusing the functions I have, and the effect I get from this part of the code is effect B, and I am running that effect B to get this result here. So moving step by step like this helped me a lot to build a good API as a library, and that's where I hit a wall, because I was able to describe computations. I was able to describe computations that can also fail. I was able to combine these in a sequential way, but I was unable to really build successful programs with this. Why? Because as your program grows, as your description tree, I would say, grows, running that becomes harder and harder. It becomes more and more complex. And when you actually run this code with a big enough program, the tree becomes so big that it leads to Stack Overflow errors. If you are familiar with JVM, you probably know what that is. And what it means is that what I need to do now is that I need to find a way to actually make this description stay in my application's heap memory. This is technical, I know, but I need to move my computations from the stack, and I need to describe my effects, my run loop myself instead of JVM's call stack, because as I keep calling, the next effect and the next effect and the next effect, the stack becomes bigger and bigger and leads to Stack Overflow. This technique is called trampoline technique, I believe, if I'm not mistaken. What I am doing is that I am moving my running logic to something I called fiber. It is not it's not a name that I only use. It is a well-known name. It is also used by other effect libraries like Zio. And I'm not going to dive too much into the details of this particular code, but what I did here was I created my own loop, own program loop, and I was able to run the instructions one by one, instructions being the effect cases. And since when you write your program, the entire program becomes this tree of your effect values, because these are just regular case classes. As you can see, a fold holds other effects, and this effect here can be a flat map. The other effect inside that can be a value, a suspend, etc. So the program you write becomes this huge value that is something like a tree, and we know that is the description of our entire program. We need a way to run that. We need a way to just start going through these effects one by one and do the thing it is meant to do. So what we end up with is this thing we call run loop, and it allows you to actually hide most of the complexity in your library implementation code, and it also allows you to be more performant by using some mutable states and stuff, while maintaining your entire application, entire library as a pure functional code base, let's say. And this fiber thing has its own stack, but it is our own data structure in our heap, so that we don't end up with stack overflow issues. And while the effect type is an immutable description of our computation, it is just a description. It's not really running the computation. Fiber, on the other hand, is meant to model the running execution of your computation. So that's the distinction. And what this effect library ended up is that it is using fibers behind the scenes, fibers that I implemented, and it has a lot of useful features. I can show you the rest of the code if I have time, but that's the path I followed. That's the techniques I use. That's the thought process behind what I built here. And I'd like to now talk about the takeaways from this presentation. I know I talked a lot. I know I showed you some weird looking, perhaps a difficult to understand code, but this topic is a complex topic, the functional effect, and that was really the reason I decided to try doing something like this myself. It definitely helped me understand the complexity of these libraries better. It definitely made me appreciate what we currently have in Scala community, this really powerful and complex libraries. So the takeaways are here. One takeaway could be that declarative encoding, using declarative encoding style, can help you to separate the definition of your computations and their executions. Because I was able to just describe my functional programs in just pure values, I was able to work on the runtime of that, the run loop of that somewhere else, and they were really separated, and it also allowed me to hide most of that complexity. Another takeaway is that being lazy was important because I wanted to achieve these things. I wanted to be able to just describe things, not run them directly. I used lazy parameters and lazy values and stuff, and this also let me write referentially transparent programs. For those of you that don't know what referentially transparent programs are, you can think of it like if you replace one value, one expression with the evaluated value of that expression, you should get the same exact program. If I go back to the beginning, if I replace, if I take this value out to another value, I am able to reuse that. I am able to extract this into its own value. I am able to then just update that easily without breaking the behavior of my program. How this is achieved is a bit more technical, but if you are familiar with Scala and if you are familiar with Scala's features, they are not referentially transparent in cases like this. If this was a feature and I extracted it to a value outside, I would not be able to use that value here and use that value again later if I wanted to, because that computation of printing the string would already have started, and it would have printed to the console once when I don't want it to, and it wouldn't print the second time. That means that moving an expression, moving a value out of the place it has and replacing that with the return value of that, actual computed value of that, program behavior changes. This happens if your program is not referentially transparent. What effect is referentially transparent because it is lazy. It is not running this side effect at all. It is just describing how to do that. So if I take it out to a value, if I reuse it, if I update it, refactor it, I can do that easily without breaking my program. So let's go back there. That was one other takeaway. And another thing is that the public API of your library is important if you are designing a library. So it is really important to spend time on your API design. If you remember, I wanted to have flat map and I wanted to also have map. And I may want to have another method called map2, I don't know. And if I am thinking of that map2 method, I found that I need to ask myself these three questions. Would my users actually need this map2? Is it something that serves a good purpose? Would this map2 implementation or its signature change in the future? Because this thing is a library, I cannot freely update the code I want, the way I want. I cannot just remove stuff, I cannot just rename stuff, because that would be breaking the compatibility of my code. And if someone else is using my code, because they will, this is a library, it will also break their code. So this question is also important. Would this thing change in the future? I need to think about that too. And lastly, I need to think about, can this thing be implemented in terms of other things? That was the case in my map implementation, for example. I did not reinvent the wheel, if I may say. I just reused the existing flat map implementation I had. And lastly, managing concurrency is really hard because I am still having issues with the asynchronous part of my library. So you are welcome to contribute if you want to. This entire effect library is open source. It is, if I remember correctly, using MIT license, and it is, even though it is just an experiment to me, it started as just an experiment to me. It's actually pretty powerful, and on GitHub I have this project for this repository, and I am currently looking at the board like a board like this. There are things I still need to do. The documentation isn't great. There are a few issues with the code that I noticed after releasing the project, but it is released. It is a project already available to use. So if you are curious, please go ahead and try this. You may contact me on my website, on many different platforms. This is where the code is. So you can come here and check it out. I actually released 0.2 version yesterday, just with some minor updates. As you can see, the code is already available as a dependency. It is only for Scala 3 now, so be mindful of that. And thank you very much for listening to me.
Okay, Akif, thank you. Thank you very much.
Thank you.
Do you have any questions to Akif? You're in the office or maybe on the chat? Hola, do we have any? No, at the chat there is nothing.
Okay. Feel free to reach me. I will be available, and I'd love to talk to you more about this. Thank you for listening to me.
Yeah, you have also contact to Akif on the chat, so you can find him on his website. Thank you very much, Akif, for this presentation.
Thank you.
Okay, guys, so now we will have around 20 minutes break. So see you after that during the next presentation with Wojtek. Thank you. We are back. Monia. Hello again, we are back. Wojciech is with us. So, love, hate, and workflows. Let us know if you can see our screen, if everything works. And, well, Wojciech, the stage is yours. Maybe I will make some changes. I think now it will be better.
Perfect. Okay, so before we begin, before coming here, I checked, and one of my very first public speaking opportunities was on this meetup, or almost this meetup, previous edition, like 5 years ago, Functional Tricity. Now, after 3 years of break from any public speaking, I'm back, so it's really nice. And today I will talk about workflows and my love and hate toward them. So let's start with a little expectations management, and let me tell you what this presentation is and isn't. So it's not a tutorial. I will not teach you how to use the products, the tools visible in the description. It's not a deep dive, so I will not explain how those tools work. Also, this talk is not Scala heavy, or really like programming heavy, or functional programming heavy. So I don't think there's even a single Scala slide here. But still, all the things I will be talking about, I dealt with from Scala. So that's my background here, and this is the context from which I'm speaking. So what this presentation is, it's a problem introduction. So I will tell you what is a workflow and what challenges it comes with. I will do a quite shallow comparison of 3 different solutions to this particular problem. And then I will tell you why those solutions work and don't work in practice. So in terms of, again, agenda, it's the problem definition. I will tell you a little bit why I'm talking about this, what's my experience with workflows. I will tell you about the few main challenges I tried to identify, how different solutions help with them, and of course I will tell you why everything is broken and it doesn't work. And then a few key takeaways at the end. So what's a workflow? Maybe before going to definition, let's go with a few synonyms that you may have heard. So long-running process, persistent state machine, business process, service orchestration, process orchestration. In many cases, all of those things will refer to the same group of problems. So I tried to come up with a short definition of this. And this is the shortest one I managed. So it's a series of steps with internal state that has to survive a system restore. It's not a good one, and it probably describes most of computer systems in existence, but still, it's a short one. A little bit longer definition is that it's a process that spans from few seconds to few weeks. Typically, it can be longer, maybe it can be shorter. It involves waiting for something, either human interaction or a synchronous response from some other system, and it has some internal state that has to be passed and kept between the steps. So let's go with few examples to strengthen your understanding. So the first most common example is a shopping cart. So you try to buy something, and let's say the system crashes during the preparations of the preparation of the parcel of the shipment. You don't want a client to start the process from scratch. Especially, you don't want him to pay again, right? So another example, a money payout. So let's say you're a bank, you want to send money away. So the user inputs the details, then you take the funds out of his balance, and then you run some kind of checks. Let's say you have a suspicion it's a terrorist financing transfer, and you stop it for a human review. And after a few hours, the human decides it's okay and you release it away, right? So it can take a few hours. Another example from one more different domain is software installation. So let's say you want to install a piece of software on some machine. And to do that, you need to connect to that machine, trigger the installation, provide them the license, check if the installation was completed successfully, and if not, notify IT support that something went wrong. And here you once again need to wait for this IT support to mark the installation as complete. So why am I talking about this? So for the more than 4 years, last 4 years, I worked in 2 different companies on 3 almost completely different products and kind of 3 different domains. And overall, I think I dealt with at least 2 dozens of different workflows or processes. So at the beginning, I worked at Sony at security automation. So there is Sony Electronics is quite a big company, so you have a security department, let's say 100 people. Those people are engineers, but not software developers. They have a lot of custom processes, like the software installation example is just one of them. And they want this to be automated, so it takes as little time as possible. So there was a team of few developers that tried to automate all of that. After some time, we learned that we need to go faster. So we tried to investigate ways to bring time of delivery to something around a few weeks. So when the new process was requested, we tried to be able to build it in 2 weeks instead of 2 months. On top of that, we wanted to build also a self-service platform. So as I said, those people were engineers. So they were capable of writing simple scripts, like let's say Python, Bash, whatever. So they should be able to automate some stuff on their own, assuming we provide them enough infrastructure. It didn't turn that well, to be honest. And now I'm working at Swissborg. So I'm a software engineer there, and I deal with money processing. So all kinds of input and output from the app, inflow and outflow of money. And as you can imagine, this kind of transactions are also workflows. So this presentation is based on few main challenges I identified when working with workflows. There's 4 of them. The first one is versioning. So imagine you have your process, your workflow definition, a series of steps, and then over time you need to change it. You add a step, you remove a step, you add a conditional, like to split the flow, whatever. And then you need a strategy for doing something with your already running instances. Like as we said at the beginning, a workflow can take up to a few weeks or maybe even months, right? And if you have enough load, over time you will accumulate process. So when you come up with a new version, you have hundreds, if not thousands or hundreds of thousands of running processes. And you need a strategy of what to do with them when you deploy a new version of your process. Then another problem is the overview. So over time, these flows get more and more complicated. So you need some way of understanding what they do without really going through hundreds or thousands of lines of code. The third problem is introspection. So you have a process instance, and you need to be able to understand what happened to it, like in scope of it, what steps were taken, what paths were taken, what is the state at the moment, what was the state at the earlier stages. And the last thing is the recovery. So how do you get back to your to the current state, to the last state after system restart? So whenever, let's say, the data center is on fire and everything is down. Okay, so let's go to the solutions. But before I start talking about the solutions, I ask you, please don't do it to yourself. Yes, I like the tools I will be talking about. I worked with them for a long time, but if I could avoid it, I would really much like to do so. But if you really have to, then I will tell you a little bit about Camunda temporal and raw event sourcing system built to handle workflow. What you can expect from the next part is I will tell you how the given solution works, I will tell you why it doesn't, and how it tries to solve the main challenges I identified. So the first one is Camunda. So the step 0 is you need to pick a version to use. When I was working with Camunda, it was version 7. It was fully open source. You just download it, run it, I think from a Docker, and then it's fine. Now they modified the business model a little bit. I think it's still open source, but I haven't checked. It's definitely, there's a free version that you can run on-prem, but they also offer, they have a cloud offering, which looks really cool and is easy to start with. So basically, you need to choose. Then you define your workflow, and the workflow in Camunda is defined as a XML file. The primary way to defining this XML file is the graphical editor that ships with Camunda. So you just go and click through stuff to model what you want to achieve. So this is how it looks like. You just drag and drop the boxes, connect them, and then fill some variables on the panel on the right. The second way is the Java DSL. So if you want to do this with Scala, you have to wrap it, but we will talk about this in a second. But basically, there is a Java library that gives you this Java API to build a model using the code. Then the second step is to integrate this with the backend. So your service, you run your service. It has to connect to Camunda server, get a list of available tasks from there, mark one as being worked on, so as taken, do your work, and then update the Camunda server with the result. So there is the REST API to do all of that, so the integration is pretty straightforward. This is how you define the tasks, the so-called service tasks in Camunda. So in this graphical editor I showed you, in this panel on the right, if you mark a step as a service task, you have to type in this stuff. So for example, what are the input variables? What are the output variables? What's the type of the task? Why it's important, you will see in a second. The third step is you deploy this flow to the Camunda server. So you just take your XML file, upload it. There is also REST API for this, and that's it. Here is a little architecture comparison between platform 7 and 8. So as you can see, they changed quite a bit. What's important is that on the left, there is this bluish box called the job worker. On the right, there is the same color external task worker. This is your service. Your service lives outside of anything related to Camunda and just communicates with Camunda through the REST API. So the main challenges. Now, the first is versioning, and when it comes to versioning, I think Camunda does a really, really good job here. It just stores all historical version of a process, especially as long as you have running instances for this version. This means that when you deploy a new version that changed, it will be used for the new instances. The old instances continue to work on the old version. On top of that, you have an API to migrate the instances. So you can say, take the process from this, all the processes, and the ones that are in step X, move them to the new version at step Y, and maybe modify some state when you do this. So the support is really cool. The next challenge is the overview. So as you have seen, Camunda relies on the XML and the graphical editor and the graphical representation of the processes. So here it's also quite good. Also, you can see this graphical representation from your server. So the flows actually deployed. The third one, introspection. So if you go to the Camunda server UI, you will see all the instances. You can click into any of them. Then you will see all the variables it has, all the steps it has taken. Here is the screenshot. It's not that well visible here on the screen, but some of the arrows on the diagram are blue. So the server even shows you where is the process now and which path has it taken like till now. You can also see all the tasks that were executed, all the variables, so all the state of the process instance. So it's really cool. And then the recovery is here, non-existing process, it just works. Not existing problem, it just works. Camunda takes care of all of that. So it sounds too good to be true, and to be honest, it is. Camunda comes with many problems. First of which is it's very easy to create an invalid workflow. So once you have your XML, you need to validate it. To do that, you probably want to build a linter, and this is work. Camunda comes with some sort of the validation, but like at least 2 years ago, it was not good enough. Then, the graphical editor is not a way software developers want to create products. We want to write code. This editor is not even close to the IDE we are used to. So to migrate away from the graphical editor, you need to use the API. As I said, there is only Java API, which is a good baseline, but it's not good enough for daily users. So you have to build your own DSL on top of that. So it's even more work. Then the third problem is that workflows are fragile. As I said at the beginning, it's easy to create invalid one, but even if you create something that is syntactically or even semantically valid, now it can still break. And so you need to have some kind of testing infrastructure. So something that will allow you to build unit tests for the workflows without deploying them to the server. And part of this support is provided by Camunda, but once again, it's not enough. You need to build on top of that, for example, integrate it with the Scala test, and it's even more work. Another problem, the Camunda workflows depend on the global, mutable, dynamic state. And as I said, you probably will be building a DSL to build the workflows, but then if you want to match your workflow definition with your server that handles the tasks, this DSL has to become crazy complicated. Like it's enormous amount of complexity. And yes, there is more of that. I could go longer, but maybe let's finish here. The bottom line here for me is that if you have enough load and resources to pay for the tooling and complexity needed, it's a really great product. I would really love to build something on top of Camunda if I had a team of like, let's say, 1,000 developers fully committed to this. Then great. But I doubt that any significant number of companies is able to pay for that. So the second solution that we investigated and experimented with was temporal. A little bit of history maybe, that temporal was started at Uber. It was then called Cadence, I think. Then the guys who created it, they started their own company called Temporal. So in temporal, it works a little bit different. So the first step to define a workflow is you have to define your activities. The activities are, they consist of the interface and the implementation. This is Java code. I took it from the documentation. The Scala equivalent is straightforward. It's important that you need to have the two. Why? I will tell you in a second. Then you define your workflow. So it's just a piece of code that consists of either deterministic computation, so like 1 + 1 is deterministic, current time is not deterministic because it will change over time. Or if something is non-deterministic, it has to be put into activity, and then you make calls to those activities. So here is the a piece of code showing the workflow. I should scroll down a little bit to show you the rest of it, but it's not that important. Let's just go on, and then at the end you need to have 3 conceptual servers running. In practice there are just 2. So there needs to be something that handles the activities, like executes the activities. So it's 1 server or worker. There's another server that needs to run the workflow code, and then there is a temporal server that lies in between. So how does temporal really work? When we go here, you see that the activities instance of the interface you previously defined is created through temporal API, this new activities tab. So this object will go to the temporal server, asking, like, serialize a request and send it to temporal server. The temporal server will proxy it and pass it through to your activities server. Then you will have your logic running. You return the response. Temporal server gives the response back to you. So here we basically do man in the middle kind of thingy, with the temporal being in the middle. Then when you recover, let's say in the middle of the process your workflow crashed. So then maybe I will scroll it. Yeah, it will be easier this way. So here you can see that there are 3 activities being invoked. There is this download, process file, upload. So when you execute this for the first time, let's say this the first one, activity is download. Your code goes to temporal server goes to your activities server, gets a response, give it back to you, you have your local name. Then you do the same for the process file, and then let's say this process crashed, right? So what happens then? You restarted from scratch. Temporal recognizes the process instance, so each instance has the ID, And then when you execute this code, it still goes to temporal server, but temporal server gives you the previous response back. So the activity code is not invoked again. So this is how it handles the recovery. So basically it caches all the responses and gives it back to you when you ask for them again. Okay, so this is how it works. Let's see from the perspective of the challenges. So when you introduce a new version, your old workflow must behave the same. Your old workflow instances will use the same code. This means that all the activities has to be invoked in the exact same order. And this means you need to put this kind of stuff in your code. So you check what is the version of the process, and then based on this, you make a decision of what activity to invoke. New version uses this one, the old version uses that one. And then after some time, your whole workflow becomes cluttered with this kind of conditionals. Okay, then the overview, there is nothing because the temporal is imperative by nature. There is no way to show an imperative program like draw a diagram, unless you build a DSL on top of it. If you can solve something, throw more abstraction in it will work. Then introspection, this is pretty decent. The UI will show you all the steps that flow has taken. So those are on the list on the left. All the inputs, outputs, so you have a pretty decent tool to understand what's going on. Then the recovery is event sourced in nature. This is a technical detail, but it's kind of relevant for the next point. And as I described, your workflow code runs as usual, but during recovery, all the activities that were already executed are replaced with previous outputs. So no activity is invoked again. Okay, so what problems does it have? Temporal comes with a couple of different SDKs. So it has a TypeScript one, Java one, I think 4 overall. The one that we will probably use is the Java one, and then we need to build on top of it. So it's not a pleasant job, let's say. There is a lot of magic happening on, like the SDK, for example, have the magic serialization, the serialization of all the inputs and outputs. So it was not that straightforward to plug in, for example, with a CRC library in Scala. Yeah, as I said, there are no migrations, so you have to deal with this cluttering of the workflow code. There is no overview, so you either have to deal with it or build a DSL on top of it. And the bottom line is that it's much better for creating workflows from developer perspective, because you at least write code, not click through a graphic tool. But from the perspective of maintenance and operations, it's lacking in comparison to Command. And the first solution is custom event sourcing. So the first step to build an event source application is to pick a library. And this is the list of alternatives I was able to come up with. So you have Akka, which is a primary choice, but recently there was this problem of its license. So right now, either you have to use the old version or pay for it, or wait until it's forked, and yeah, there is like a new maintaining team. Then some time ago there was a library called Aecor. I think it's no longer maintained, or at least I haven't seen much activity around it. A few weeks ago I saw something called Endless4s, but for now it's only a layer on top of Akka. Or you have to build something on your own, which is not that straightforward. Then you have your workflow, so you need to define your workflow as a set of commands and events. So external world sends commands to you. The commands execute side effects and produce events. Events are stored in the database called journal, and then based on the events, you modify the state and can produce more commands if you need. And this is how it works. Over time, you just build this journal of your instance from the events, and you can replay them to rebuild the state. So this is easy. It's simple, okay? So it's simple, but by no means it's easy. So the main challenges, the versioning, is that the old events have to work, or at least whatever you have in the journal has to work. This means either you keep the backward compatibility forever, or you migrate your journal, or you use snapshots to discard the events. But one way or another, you have to deal with it yourself. Then for the overview, you don't get anything by default, but it's not that hard to build something that will, to build a declarative API on top of it to be able to draw some kind of a diagram. This is something I've been working on recently, and it's around like few days of work to have a POC. At least for me, it was that. So it's doable. Then introspection, you have and don't have anything. So it depends how you do it, but basically it's very easy to, for example, log all the events or all the state changes or whatever. So this is not that hard, and also you can just read all the events from the journal, and this kind of give you already the introspection, a way to see what happened to the process. So it's not bad. Then recovery, as I said, the state is by default rebuilt from the events stored in the journal. Alternatively, you use snapshots, which means you rebuild the state and then persist it, and then discard the events afterwards. It comes with its own problems. Okay, so maybe there is another way to go, and kind of, the answer is kind of. So if you think you have this kind of problem, just think twice. Put your state in the database and just try to go with that. Don't employ any sophisticated solution. And I believe for many cases, this will be enough. So yeah, this presentation is kind of short. Let's sum it up a little bit. So Camunda as a tool requires a lot of work and a lot of tooling around it to be usable from Scala. So the linter, the DSL, the test support, the even more complicated DSL for your server side, like a lot. Temporal is closer to what you know from standard programming, but it comes with a cost, and as such, it's not able to solve all the problems. And then raw event sourcing is the most flexible, but at the same time, the most complicated way to go. Like it's just a tool. You have to build everything on your own, but it gives you a lot of flexibility in dealing with all kinds of problems. What I discovered when preparing this presentation is that over the last 2 years, both Temporal and Camunda developed a lot. So those are definitely not dead projects. They're improving, growing. Probably the user base is also growing, and this is always a good sign. So at least from this perspective, it seems you will be in good hands. Okay, so this is all I have. The slides are here. Probably the link will be posted on the chat, Also, if you go to the link, you can leave feedback there. And there's my Twitter handle if you want it. Thank you.
Okay, thank you very much. So do you have any questions? Here in the office or maybe on the chat? Maybe we will see if there's something in the chat. No, so far there are no any comments. Okay, so thank you, Wojtek. So I think we can start our quiz.
I think we can, yes.
Okay then, so let me share my screen.
I hope everybody is ready for the quiz.
Oh, you have one comment, great one.
Oh. Okay, so the quiz will be on in a second. So anybody who wants to participate in the quiz, they can like do a picture and just get the QR code or just go on Kahoot and type in the pin. So whoever likes any form of entering best, they can do it now. And we will just see people over here on the screen. So yeah. We'll just wait.
Yeah. Probably there are some lags on
Yeah.
YouTube, so
Yeah, it's probably some lags, so I'm just waiting. Yay, one person. Let's go.
I missed that one.
Just waiting on that one.
Let's go.
Okay, let's go. Okay, there are cool prizes that you can actually get, so. Okay, I have 3 people, so let's go. This is trying to be motivational here, so. I feel like a TV presenter, so I'm gonna say what kind of weather it is today.
You can try.
But I don't see the weather, so I can't.
Probably it's windy.
It's windy and it's dark. Okay, I'm gonna wait, I feel like 1 more minute, maybe, for people to join. So we can start, right? So we're gonna give so nobody has to wait. Oh, love pierogi.
I think 2 more minutes because I can see that. Yeah,
2 more minutes?
we have some lags, so.
Oh, okay. So 2 more minutes.
Mm-hmm.
Okay.
I'm watching us on YouTube.
Yes,
That's great.
that's awesome.
Okay, 1 more minute.
1 more minute?
Yep.
Okay,
That's it.
so I'll just.
Actually, there are 2 more questions to Wojtek.
Oh, questions to Wojtek. So maybe
Maybe after, or we can wait, or maybe after Kahoot.
maybe after Kahoot we can answer the questions. I mean, everybody is ready.
Okay.
I think we can start.
Okay. So I can start. Okay.
Oh, I can click it.
Oh.
So let's see. Everybody will see it on their screen as well, the question. So which statement is incorrect? Should I read it?
You can read questions
But answers as well?
if you want.
I don't know, maybe I'll just make a mistake and everybody will laugh at me on the internet, so no.
You're a streamer. Okay, so we have all answers.
So we have the first one was correct. Scala is a dynamical type language, and 2 people got it correct. So that is an incorrect answer. I mean, the
one-
statement was incorrect. Yes. Okay, let's go. The next question.
No, it's like
Okay, so Oram got it right, and he is the first person on
Yeah.
our.
program is online.
Yes.
Yep.
Okay, let's go. What would be the least important reason to use a functional effect? So you guys have all.
Quick tip, those are from Akif's presentation.
Yes,
As you can
you can see. This is a little hint. Hello, wink. Okay. Ooh.
Wow.
So that was too easy. The hint was too easy. Okay, so everybody got it. Oh, one person got it incorrect, but that doesn't mean anything. Oh,
Okay.
Let's
Oram
go.
is still the first one.
yeah, we have a winner. But it's a tie almost. Okay. The third question: which of the following is the best thing to do when a method call throws timeout exception? It's also from Akif's presentation. I can see. So everybody
You are
knows. Matilda, did you create those questions?
Yeah.
You're very smart. Okay, so that's amazing. Everybody, almost everybody, did it right. Don't pay attention to me.
4 out of 6.
We will see who's. Oh,
Oh.
okay, we have Angelica. That is our winner right now. So, guys, you better watch out. What is the expected time frame of the workflow instance?
And this one is from Wojciech's presentation.
And this one is from Wojciech. Wojciech cannot answer. You know that. Right. I really like the picture. It's very nice. Oh, so.
One mistake. I think Wojciech.
Wojciech.
I can see that on the
Oh, yeah, come on. Okay, we'll see who is. Oh, okay, we see we have this person winning. Angelica, great. 2 more questions, so guys, you better, be quick. I mean, I don't know any answers to
You
these
are very
questions.
motivated.
8, 7, 6.
Oh, wow, that was quick.
Wow, everybody answered very okay. Continue when it's finished. Are those questions too easy? I guess they're they're too easy.
You could
everybody.
try.
Well,
Wow.
oh,
Like
there's even a fire.
You are so quick.
Krzysztof is so quick. He even has a fire. Wow, that's amazing. Okay, we have. Is that almost the last one? Which of the solutions requires most work to make it type safe, immutable, and adhere to Scala way of doing things? No?
That was one one.
6, 5.
Thank God we got 20 seconds. That's all.
Oh. Okay. So we will see who is winning right now. Whoa! Once again, Oram also has a fire here at his name, and he is winning right now. This is the last and final question, so I'll just make a little maybe drum roll or something like that, and let's go. True or false, yeah. And this is also from Wojciech's presentation. Okay.
That was tough one.
Yes, I think so. So we will see who is on the third place.
Third place, Angelica.
Woo, yay! Second place.
Oh,
Oh, so
yeah. Are you online? You can write your email on the chat on YouTube.
Krzysztof.
You are Krzysztof, or no? No, you're
No,
not.
no, no.
Okay, so we have
can
okay.
2 people online and one Angelica. So
Thank you guys. That was so exciting.
Yeah,
And
we have Angelika here, so we have also a gift for you.
okay. So we are right now going to create. So Krzysztof, because we don't have Krzysztof here, so Krzysztof, can you
For
write?
the first place, it's our hoodie. Like no, it's not hoodie. It's our but it's very warm one. So during our winter, it will be very great. Present. I don't know if you have maybe another size. Sorry.
Oh, it's fine. I guess we can have plenty of sizes.
Okay, so maybe we can check it
Yeah.
after the presentation. So Wojtek. Okay, so Oiram and Krzysztof, please write your emails on chat.
And we will contact you.
Yeah, or reach me out because you have my email on the stream's description. Yeah.
So
And Wojtek, we have 2 more questions, so maybe you would like
I will
to answer.
Thank
Yeah. Okay. So the first one: would you recommend event sourcing for greenfield projects?
No, definitely no. Like I would, or it depends. Like I would recommend it on the if you have experienced team knowing what they're doing, or the project doesn't really matter. If it matters and you don't know what you're doing, it's hard and don't do it. Like it has its uses. It solves very particular problems, but it's not a convenient approach. I would say the typical approach, like just go to the database, read the state from there, is just a little bit easier and more convenient as a default.
Okay, and the next one is also from Mario. And if possible, would you share some implementation examples as well afterwards?
Unfortunately, no, probably not. I don't have access anymore to the code written based on the command temporal. So even if I could do it, I just simply don't have the code anymore. So you have to rely on the examples online. For the event sourcing, you can reach out to me. Maybe I can share something if you're interested in a particular aspect. Like overall, it's too hard to minimize the code into something meaningful. So yeah.
Okay, so that's it. That's all questions. So thank you guys for today, and thank you for joining also here in the office. And well, see you next time. Thank you very much.